All right, so we're looking at problem 12 from the week 3 assignment. Now, this one is pretty challenging. Now, the challenge for part A, which is what we're referring to, not part B, we're looking at part A, to find the expected profit um, for Andy, the person playing the game. So to find the expected profit, you have to put the values in terms of how much Andy would be making. It could be negative, it could be positive, and you need to keep track of each possibility and its respective probability. Each respective outcome with the respective probability. So to do this is to make a discrete distribution using a table, and remember, this is in terms of Andy's profit. All these values. So we'll call that X. X is Andy's profit, and there's several different outcomes we can have, and we're going to have a respective probability for each of these outcomes. Okay, so here's the game he is considering playing. The game costs $2 to play. So he's already going $2 in the hole. So we're going to have to subtract $2 out of each outcome. So he then, so remember that. It costs $2 to play. So we're going to have to remember that once we start figuring out each value of X, which is Andy's profit. So we're going to have to subtract 2. He draws a card from a deck. If he gets a number card 2 through 10, he wins nothing. Okay, so he wins nothing. So the outcome is 0 minus 2. So actually that would be minus $2 net in total. He would be losing $2 if he gets a number card because he has to play the game negative $2 already, and then he wins nothing. So he, in that outcome, if he gets 2 through 10, he's losing $2. Now, the probability of losing $2 in total, we have to figure out the probability of getting 2 through 10. So remember that there's 13 different cards in terms of, 2, 3, 4, 5, all the way up to ace, Jack, King, Queen, King, Ace. There's 13 total different cards. 2 through 10 makes up 9 cards. If you count it up, 2, 3, 4, all the way up to 10. That's 9 out of 13 of the different types of cards. Not including suits, of course. We don't care about suits. Okay, at least for this. Okay, so for any face card, which is Jack, Queen, or King, so that's 3 out of 13. We're going to be figuring out here. We should be able to figure that out already. Okay, so that's 3 out of 13. Probability of getting a Jack, Queen, or King. He wins $3, but he's paying $2 to play the game. So in total, that would be a positive 1, or just 1. That would be his profit. He loses $2 to play, and then he gains $3 if he wins by getting a Jack, Queen, King. So he gets $1 in total, net. For any ace, he wins $5. Okay, so if he gets an ace, he wins $5. So keep in mind that, okay, so let's read this whole sentence. So he wins $5, and he wins an extra $20, so that's $25 if he draws the ace of clubs. So so there's 4 different aces. 3 out of those 4 aces, he's just going to win $5. But it costs $2 to play the game, so that's $3, a positive $3 he would get if he gets one of those non-clubs, but an ace. So that's 3 out of 52 cards. Okay, so that leaves 1 card, so that's 1 out of 52, that ace of clubs, where he would win an extra $20 on top of that, on top of the $5 he'd win. So he'd win actually $25. So that would be 20 more than this, so that's $23 he would win. Andy's profit would be $23, but that would only occur 1 out of 52 times. So this is the distribution that you want to find the expected value of. So keep in mind, I was focusing on the expected profit for Andy. So I wanted, so I mean, there's a lot of outcomes, 9 out of 13 chance that he would get -2. And if you want, you can write this in terms of, with the common denominator with 52, which would be just 4 times that, which is 36 out of 52. And this would be 4, so it's 52, so 12 out of 52 for winning $1, and then 3 out of 52 and 1 out of 52. Now, that might be a little bit easier using those 4 outcomes here, each of these 4 probabilities. And I'm going to stop here, but you should know the expected value equation. It's widely discussed in this section, so you can read up on that. But this is how you build your distribution. This is the hardest part of this problem for part A. Actually, for all of this problem, compared to B also. So keep in mind that you need to pay attention of what we're trying to find the expected value of. It's Andy's profit. It's Andy's profit. So you need to pay attention to what's negative and what's positive and to find the probabilities for each of those outcomes, how I did here. Okay, so hopefully this makes sense. I think everyone has the same, don't quote me on this, but you might want to check to make sure that you actually have these same values here. I can't remember if everyone has the same values for this one, but if they are different values, you'll have to build your distribution. If not, if it is the same values, then here's your distribution right here. But you built it the same way with this sort of thought process. So hopefully this makes sense. Let me know if you have any concerns. I will be more than happy to help.